And we're on. Here we go. So let's go here. All right, so we're at number 8. Okay? Number 8 on page 80 said, write 243 base 5 as a base 7 number. Okay? So this is number 8. I want to change 243 base 5 into a base 7 number. How the heck are you going to do that? Well, we know how to convert from base 3 to from whatever base we want to base 10 using int. I guess I could convert this to base 10 and then convert to base 7. We only have a few that convert to a particular base, like bin. Like bin of this int gives you a binary integer. Oct of this int gives you an octal integer. Hex of this int gives you a hexadecimal integer. So I can convert from decimal to another base, but only certain ones. So this doesn't, I don't have one for base 7, do I? All right, so let's do what we can do on Sage. What can we do? We can convert from base 5 to base 10. How? Int of, quote, 243, close quote, comma what? 5. So I'm putting in a string. It's going to spit out an int, and that int will be a base 10 number representing 243 base 5. Is that right? Well, you could do that in your head. If this is base 5, the 3 is in the what's place? 1. The 4 is in the what's place? 5. And the 2 is in the what's place? 25. So 2 times 25 is 50, and 4 times 5 is 20, and 3 times 1 is 3. So 50 and 20 and 3 adds up to 73? So did we really need Sage for this? Not really. All right, now that we have 73 in base 10, how do we convert that to base 7? Well, let's think about it. Let's see. If I have one place in base 7, what's that placeholder? 1s. If I have 2 places, what's that placeholder? 7s. If I have 3 places, what's that placeholder? 49s. Do I need any more places? Well, what's the next one then? A lot, really? How did you get each one? You multiply by what? 7, right? Yeah? Yeah, go ahead. So 1 times 7 is 7. 7 times 7 is 49. 49 times 7? Really? Is that tough? 343. Do we need 343 to represent 243? No, so forget that. All right. So now it was 1, 7s, 49s. Okay, how many 49s do you need? 1. Well, rough figures. If it was 50 to 250, you would say, what, 5, right? Is 5 good or is 5 too much, too little? It's near 5 at least. What's 5 times 49? 245. Too much, right? So make it 4. What's 4 times 49? I can't. I'm just doing number 8 right now. All right, I'm sorry. 4 times 49 is what? Well, it's 160 and 36, 196, right. So what's 196 from 243? 47. All right, so how many 7s do you need? 7 goes into 47 at most? 6. Okay. And 6 times 7 is 42. From 47 leaves? 5. That's how you do it. All righty. That's all. I'm avoiding using the smart notebook thingy. All righty. Now, let's take a look. That was 8. All right, what about 9? All right, number 9 says, why do I have to go up? Well, I did a lot of stuff on the smart board, so I skipped 6 and 7, but I got 5. What do you? Yeah. That's 5. That's 4. That's changing 15 base 10 into something base 3. All right, we don't have a command to change the base 3, so we did it by hand. You want me to print it? I'll print it. Who needs a printout? Anyone need a printout of this? Just that one thing? All right, so all you need really is 1A. Do you have 1A? And 1B? And 2, Don't you have a neighbor? And 4 and 5? Why don't you look on with your neighbor, or I'll print it. I can't stay here all day. You good? Okay. All right, so number 9. Number 9. Let's see how far I can get away without using a smart notebook. Number 9 says calculate 201 base 3 plus 12 base 3. Okay. What's 201 base 3 plus 12 base 3? Whoops, I meant to write base 3 here. And again, we don't have a way to do this in Sage, so just do it. All right, so we're in base 3. Remember base 3? What's 2 plus 1? What's 2 plus 1 in base 3? What's 1 more than 2? Can't you count? Come on.
Wait, in base 3?
In base 3.
So it's 1, 2 in the 1s and 1.
2 plus 1 is? 1?
Wait, 2 plus
5? What planet are you on?
Wait, how's it not 5? How's it not 5?
Look, all right, remind you what's going on. In base 3, how many digits are there?
1, 0, 1, 3.
0, 1, and 2. So count. 0 plus 1 is 1, plus 1 is 2, plus 1. You ran out of digits, so it's got to be, when you run out of digits, you carry, no, not 11. 10. 10 in base 3 means 3, doesn't it? Because it's a 1 in the 3's place.
Yes.
So it's a 0, carry the 1. All right, so what's 1 and 1? I carried a 1, so what's 1 and 1? 1 and 1 is 2. And 2 and nothing? 2 and nothing is still 2. There you go. All right, then it says subtract. See what you get when you subtract these two numbers. All right, so I'm going to call that 9A. And now let's do 9B. Okay, I'm going to make it 9B now. So can you subtract in any base? Can you add in any base? Yes, you can. All right, so now I'm subtracting. All right, so what's 2 from 1? You can't subtract 2 from 1 until it's bigger than 2. So you look at the 0 in the 3's place, but there's nothing there. So look at the 2 in the 9's place, isn't it? 9's place. So you leave 1 9, bring over 10 3's, then borrow from 10 3's, leave 2 3's. Now you got 11 3's minus 2 3's is 11 1's minus 2 1's is... What? 11 minus 2 is 9? Are you crazy? It's 2. What is wrong with you people? Guys, when you get good at this, you're not there yet, sorry. When you get good at this, you got to do this in your math class and freak out your math teacher, okay? Because they only want to do everything in base 10, right? All right, so like whatever problem they're doing, just in your head, do it in base 5 or something, you know?
By the time I'm good at this, I'll be in your class.
Then freak out that math teacher, yeah, that other guy. No, you don't see it? Oh, I'm going to have to do smartboard. Oh, God, you made me do it. Here we go. Okay, smartboard. Are you really that smart? Okay. Come on, wake up. Get rid of this. I don't have to line it when I'm doing this. Okay. Okay, look. Let's do it again. Ready? I'm going to start over. This is number 9. What is, give me a pen. How about red? All right, let's start over. Let's do the adding part again, all right? What's 201 base 3 plus 12 base 3? I hesitate to say 12 base 3 because then you think it's a normal base 10 number, all right? So 1 more than 2 is 10, carry the 1. Ignore the 0. 1 and 1 is 2, and 2 and nothing is 2 base 3. Good, perfect. Now do the same thing but subtract. Same numbers but subtract. Okay, here we go. 2 from 1 you can't do until it's bigger than 2, so you look at the 0 in the 3's place. There's nothing there, so look at the 2 in the 9's place. Leave 1 9, borrow 10 3's. Because when you carry or borrow, you always carry or borrow 10, no matter what base you're in, because 10 in base 3 means 3. Okay. But now why did I need that? To borrow for this. So borrow 1 from 10, you get no 9s. 2. And you bring over 10 and 1 is 11. 11 minus 2 is 2. No, because look, think about it. 10 is a 0 in the 1's place and 1 in the 3's place. So that's really 3, right? So when I borrow, I leave 2. But I'm borrowing 10. So I had 1 and 10, that's 11. But what is 11? 11 is a 1 in the 1's place and a 1 in the 3's place. Isn't that really 4?
Okay,
So 4 minus 2 is 2. 2 minus 1, if you don't have to carry or borrow, it's normal. 2 minus 1 is usually 1. And 1 minus nothing is 1. You don't. It's normal adding and subtracting unless you have to borrow or carry. And say what it is, it's base 3. All right, there you go. So, now look at number 10. Number 10 says, how do you know when a base 3 number is even? Now, give me some even numbers in base 10. 2, 4, 6, 8, 10. What if we convert these to base 3 and see if there's some kind of a pattern? How do you write 2 in base 3? 2 1s. How do you write 4 in base 3? Do you need, all right, remember the places. You got the 3's place and the 1's place. So, 1, 1, okay. Now you got the 3's place and the 1's place. How do you write 6? 2, 0. Oh, now you're getting it, okay. All right, now I got the 3's place and the 1's place. Do I need the 9's place? No. So how many 2's? 2 2's is 6 and 2 1's is 8, right? Okay. And how would you write 10? Do you need a 9's place? So it's 1, 0, 1. So all of these base 3 numbers are even. Do you see any pattern, anything they have in common so you can tell ahead of time? Well, I'm thinking that the digits add up to an even number. 2, 2, 2, 4. I'm thinking base 10. 4, 2, right? Let's try it again. How do you write 12? You need a 9. You need a 9. Then do you need a 2? Well, let's see. 9 from 12 leaves 3. So I need a 3. Do I need a 1? No. All right. Why don't we write the odds to see what's going on? I'm going to write the odds and see if the pattern is different. How do you write 1 base 10, 3 base 10, 5 base 10, 7 base 10, 9 base 10, 11 base 10 in base 3? Well, you need a 1 in the 1's place, right? You need a 1 in the 3's place, right? Now what? A 1 and a 2. Good. Okay, now what? A 2 and a 1. Now what? A 1 and a bunch of zeros. Now what? All right. So we can answer both questions. When is a base 3 number even? When is a base 3 number odd? When the digits add up to even or when the digits add up to odd? 3, 1, 3, 3, 1, 1, 2, 2, 2, 4, 2, 2, right? There it is. Yeah.
Why wouldn't 12 be 102?
12, 102. Did I do that wrong? Hang on. 1 is in the 9th place, so 9 from 12 leaves 3. 1 in the 3's place is all I need. Another 3. Right? If you wrote 102, you would get 11. Look, that's 11. 102 is 11. 2 1s and a 9 is 11. So 102 is 11, not 12. 110 is 12. Okay, guys, you got to know how to count. Okay? I mean, really. Are you ready? Let's see. How do you count in base 2? 1. Now, counting is easy. You're just adding 1. Now I'm in base 2. So what are the only digits you're allowed are? 0 and 1. So if I add 1 to 1, I got to carry. So what do you get? 10. All right, so 1, 2. How do you write 3? I'm in base 2. 1, 1. Now if you add 1, you carry. If you add 1, you carry. So what do you get? 100. Add 1, what do you get? 101. Add 1, what do you get? 110. Add 1, what do you get? 111. Add 1, what do you get? 1,000. No? Because when you add 1, you ran out of digits, you carry. But you got another one to add, you carry. You got another one to add, you carry. This is in base 2. How about, let's do base 3. Let's do the same thing. All right, what's 1 plus 1 in base 3? 2. What's 2 plus 1? 1, 0, right. What's 10 plus 1? 11. What's 11 plus 1? Huh? 1, did I hear it? 1, 2? All right, now be careful. What's 2 plus 1? 0, carry the 1, right? 2. Add 1 to this. So what? What calculator? I don't have any calculator. That's why I have them on the computer. All right, add 1 to this, you get? 2, 1. Add 1 to that, you get? 2, 2. How about we go one more? 1, 0, 0. So do you know how to count? All you're doing is adding 1. All right. Base 4. Why not? 1 plus 1, 2. 2 plus 1, 3 plus 1. Right. 10 plus 1, 11. 11 plus 1, what? 12. 12 plus 1, 13. Why? Because the biggest digit is 3. Are we okay with this? So add 1 and you get 20. Because you have a 2. The digits here are 0, 1, 2, and 3. The digits here are 0, 1, and 2. All right, add 1. 21. Add 1. Add 1. Add 1. 30. Okay, so you get the idea? Okay? All right. So, all right, there you go. All right, how about this? Let me ask you this. What's the biggest 4-bit number you can write? What does bit mean?
It's the smallest thing in a computer.
Right, a binary digit, a 1 in base 2. Right, the smallest piece of information that the computer can handle. What's the largest 4-place binary number you can write?
3.
What's the largest digit?
3.
No. I want a 4-place number in base 2, the largest one you can write. 1, 1, 1, 1, right? Okay. What is that in base 10? A 1 in the 1's place, a 1 in the 2's place, a 1 in the 4's place, a 1 in the 8th. So 8 plus 4, 12 plus 2, 14 plus 1, 15. Okay. What's the largest 4-place number you can write in base 3? 2, 2, 2, 2. Right. All right, so what's that in base 10? Well, you got 2 in the 1's place, 2 in the 3's place, 2 in the 9's place, and 2 in the 27's place. So you got 54. 2 times 27, 2 times 9, 2 times 3, and 2 times 1. So you got 60, and 19 is 79? Okay.
The last one's supposed to be a 2.
Oh, I copied it wrong. Whoa, you're right. That's a 2, so an 80, right?
Yeah.
Yeah, wait. 2 times 1 is usually 2. Yeah, that's where I messed up. That's good. Great. You know, I know how to do this. All right, is Eddie good now?
Yes.
Okay. All right, let me skip around a little bit. What's the largest 4-place number you can write in octal?
7.
Octal means base 8, so the biggest digit is 7, right? So 7, 7, 7, 7. All right. What's the largest base 16 number you could write? We haven't talked about this. Wait, there's 16 digits, right? What are they? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Did we talk about this?
No.
When they run out of normal digits, they use letters. A, let's see, 9, 10, 11, 12, 13, 14, 15, right? A, B, C, D, E, F. So what's the largest 4-place number you can write in hex? F, 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 F. Okay. That's base 16. Why am I using a regular mouse? I was just using a regular mouse. All right, back to the tablet. All right, but how big is this stuff? How big is this number? It's really huge because it's 15 watts, ones, and 15 watts, 16s, and 15 watts. What's 16 times 16? 16 squared, really? You don't know your perfect squares? This is the ones place, the 16th place, the what place? 256. Times 16, 4,096. So you got 15 times 4,096, plus 15 times 256, plus 15 times 16, plus 15 times 1 is a lot. Oh, okay. Alrighty, so we are done with 5.2. We're doing 5.3 tomorrow. That's it for today. Save your work. Come on, save your work. Good. What is okay? All right, so we're in 5.3 tomorrow. Page 81. We'll skim the chapter, the section 81, 82, 83, 84. Then we'll do the exercises in 85. All righty. All right, so I better republish this thing. See ya, and save and quit it. And get rid of this, or go over here. Bye-bye, YouTube. See ya.